Welcome back to Mountain Bike Physics. I'm Tim Graham, and today we're going to investigate a little bit coefficients of friction. We've got a lot of snow here in southeastern Michigan in the last few weeks, and then we had a little bit of a melt. So yesterday, I think it was January 15th, decided to get out and see if we could ride the single track. So my buddy Mark and I came out here and found that the snow on the trail was still pretty deep, and what was there was wet, so it was almost impossible to get through with our regular mountain bike tires. So we decided to ride the paved trail instead. Beautiful paved trail here at Mayberry State Park, and we got through most of the trail, but there were lots of places on the hills in particular where the ice was just a sheet across the trail as though it was glass, and we could find absolutely no place whatsoever to get any traction at all. And so we decided to come out here again today to talk a little bit about coefficient of friction. I changed out my bike. This is my winter bike. It's a hardtail 29er, but what's unique about this is it's got two spiked tires. So mountain bikers are very aware of how important the proper contact patch is between your tire and the ground. Too big of a contact patch would slow you down under certain circumstances. Too little, hard to gain traction. But in this instance here, our tires were decent mountain bike tires yesterday, and yet we couldn't get any traction whatsoever due to the fact that the contact patch had a minimal coefficient of friction. So the physics here is coefficient of friction. Today what I've done is I brought my bike out that has panhead screws in the tires. It adds a significant amount of weight to this bicycle, but weight's not really that important in the winter time. I have 120 panhead screws. I think they're 1/4 inch panhead screws in the front and about 100 in the back on the drive wheel, and significantly changes my coefficient of friction in the positive direction that allows me to climb and to descend all those hills yesterday that we had to walk our bike, and even walking our bike was treacherous. You can see that there are some screws that are coming through my tread here. These spikes provide me with a much better grip, and we'll see that later on in the video. I have about 100 in my drive tire, my rear tire here. If I keep it weighted, I get pretty good friction with the trail surface. And on my front tire, which is my steering tire, obviously, I have probably about 120 of these panhead screws, and you can see a couple of them here side by side, and one coming off the edge here. When this tire flattens out on the trail, try to run it with about 26 psi. I get a really good grip even in icy conditions, and we're going to see that as I tackle this hill both up and down. Last night I could hardly walk up and down either one of them, let alone ride my bike, but tonight I'm going to try to ride my bike. Sense of how slippery it is. My shoes are actually pretty good. Whoa! The things that you ask your equipment to do sometimes for the sake of science instruction. You just saw my biking helmet sliding down the hill here on this glassy like ice, and continues in this direction. This is a pretty difficult trail to even hike up, let alone ride a mountain bike up. But when you put the spikes in your tire, you certainly change the coefficient of friction significantly. So I'm going to bike up and down this hill now with my mountain bike.